This is a work and energy theorem problem, and it deals with an acorn that falls from a tree, and it falls about 10 meters with a speed of 11 meters per second. So here's our acorn. Here's kind of the top of the acorn, the bottom of the acorn, and we know that when this acorn falls, it has air resistance in this part, but for what we're doing, we want to find out what would be the speed of the acorn at the bottom if there was no air resistance. So it should be higher than the 11. So this one is with air resistance, and the one that we're doing is without air resistance. With air resistance, we know we'd have a force going up, and this one we don't. The only force we have is the force due to the weight of the acorn, or the force due to gravity. We also know that on the way down there is a displacement, so because these are in the same direction, we can use the angle of 0. The work is equal to the force times the displacement times the cosine of the angle. For this one, the force we know has to be m times g, and then we'll multiply that times our displacement times the cosine of the angle. Watch out, this is in grams. We don't want grams, we really need kilograms, so we're going to divide it by 1,000. We get 0.015 kilograms. We'll plug that in down here, 0.015 kilograms times gravity, which is 10, times the displacement, which is 10, times the cosine of 0. And remember, the cosine of 0, this ends up being just the value 1. If you multiply all of your numbers together, you will get 1.5 joules. So that's the amount of work. The problem is they didn't ask us for work, they asked us for speed. The work energy theorems, or WET is what I sometimes call it, says that work is equal to the change in the kinetic energy of a system. So let's go ahead and let's plug everything in. We know that 1.5 joules is the work. Kinetic energy is 1/2 mv squared. And if we go ahead and plug in our 1.5 joules, this is equal to 0.5 times the mass, which we said was 0.015, times the speed squared. We can rearrange everything and solve for v. V should be equal to, when you get done, 14 meters per second. So obviously the speed is higher without air resistance than it would be when you have air resistance. Did air resistance do positive, negative, 0 work on the acorn? They want to know why. It does negative work, and it does negative work because we know going up is the force of air resistance, on the way down is weight, and we know that this object is moving down. So if we draw the force of air resistance again and put in our delta R, we see that there is a 180 degrees between the two, and the cosine of 180 degrees is negative. And so that's why our work is negative from air resistance itself. The next part of the problem, which is letter C, says how much work was done by the air resistance. We know it's going to be negative. We just need to figure it out now. At this point, we're going to say that the net work done on the acorn should be equal to the change in kinetic energy. We can draw our diagram again. We know that we have the force of the air resistance. So the force done by air resistance, we'll put Fa here, is opposite to the to that change in displacement. And we know that we have mg on the way down. We can also call that the work due to gravity. So we've got work due to air resistance going up because of the force, and we have work due to gravity going down. Let's add the two together. So in this problem, what we'll do is we'll say that the net work is equal to the change in kinetic energy. That means the work due to gravity plus the work done by air resistance should be equal to the final kinetic minus the original kinetic energy. The original kinetic energy is 0 because it's not moving at first. We know that this value is 1.5 joules, we did that earlier, plus work done by the air resistance should be equal to 1/2 mv squared. This speed, remember, is not 14. This is the original 11. So that's the speed that we'll use. We now have air resistance. This is 1.5 joules is plus, so 1.5 joules plus WA is equal to 0.5 times 0.015. and we need to then put in our speed, original speed with air resistance of 11, and that would be squared. When you get done, you should end up with work due to air resistance equal to negative 0.5925 joules. And we did say it was negative. That kind of proves it as we go through. For the very last part of the problem, they want to know what is the average force of air resistance. So we know the work done by air resistance should be equal to the force of the air resistance times the displacement times the cosine of 180 degrees. We said the work in the previous part here, we said the work of the air resistance is negative 0.5925. That should be equal to F of air times 10 times that cosine of 180 degrees. And when you solve for the force of the air resistance, you should get 0.05925 newtons. That's a really good AP problem. It has you do several things to really triple check your understanding of both the concepts and the math.